We're going to talk our way through some of the history, some of the background, why this stuff's important. So again, the point of this class is to give you guys enough of a foundation and understanding what happens behind websites, so that if you have problems that exist when you're building and developing these sites, that you can at least be able to either figure the problems out yourselves or be able to talk to the people that need to help you to figure out these problems in order to get things resolved. Again, most websites require you to do things like have a server, definitionally. Mm-hmm. Well, if you're in a small house, you're going to have to be the one that develops that. You're going to have to be the one that can kind of knows what's going on in the back end. Like if you run a one-man shop, that's simply going to have to be the case. If you work on a team, you're going to need to be able to interact with the database administrators, database engineers. You're going to need to talk with systems engineers, systems architects, and figure out what's going on with the sites that you're developing. Again, think about it in terms of debugging. If you have a problem from a website that you've built, you find a bug, what is the mechanism you guys currently use to debug that? Up to this point in the program, what are you guys using?
That's a great question.
So let's think back to JavaScript for a minute. So you got a JavaScript assignment. What do you do to debug?
Inspect element and try and, there's the JavaScript hint I sometimes use. It's a little confusing though.
No. And then see, I'm trying to draw exactly to that point. That is a one-tiered level of programming. Okay.
Yeah.
So that means that you have everything right there and you're staring at it. Mm-hmm. Now let's imagine something a little more complex. Now we're going to have a site, a website that's publicly available, that's being hit by traffic from all over the world simultaneously. And an error starts to crop up. The process to find that error is what we're going to try to address today and throughout this course. Because the way you debug locally is very, very, very different than the way you do that out in the world, out in the wild. There are tools that you have that are available to help you with that, but you need to kind of get what's going on, and then you can start to apply those tools.
Excuse me.
And so, again, that's kind of why we're going to get into the stuff we're going to get into. Because, again, if you don't understand what servers are, why they are, what they are, how they work, where the tools are, where the pieces are that you need to be able to do the debugging with, you'll never be able to get there. So enough of the save on the stage bit, and we'll get into the actual content. Okay, so just for some history's sake, so you guys kind of have a clear framing. Way back in the days of yore, like the 50s and 60s, connections devices were basically hardwired. So that basically means you would go to one machine and you would solder in a connection, you would drag the cable to the next machine, and no matter how far away that was, and you had a constant analog signal between the two locations. You'd solder it at both ends. So this is really easy to debug because you know if there's a problem, you can find it at one of two places, right? Super, super easy. It's easy to build, it's easy to administrate because, again, it's one line. But here's the thing. It doesn't offer a level of robustness. And what do I mean by robustness? Anyone have a clue?
More complex things.
Well, it's stable. The ability to be resilient against problems. So the reason is because imagine this. Imagine someone backs over the cable that connects the two computers together and it breaks. So what happens then? You have to rebuild the connection, right, from the ground up. Mm-hmm. Now, can you guys imagine that happening with the internet as it is today?
My internet went out on Monday because of an outside line, so.
Right,
so, yeah.
One outside line. But now think about it this way. How many devices are out there?
Oh, plenty.
imagine a major line got cut. So let's say Atlanta, the major trunk lines to Atlanta got cut, or one of them at least. You wouldn't want half of Atlanta to go down.
Correct.
So direct connections like that don't work really all that well. So they had to do something called abstraction. And the reason that they do this is because when this system was designed, when the internet, or at this time it was called ARPANET or DARPANET, it was built as a secondary communication system for the military. So that's where those military dollars were going, was to build this internal communication system. And so when this was being constructed, the military said, look, if we have what's called centralized switching, basically meaning we have like the old telephone communication switch centers. You guys remember those from like the 1940s or 1920s, 30s, 40s, like old movies where you see like the young, beautiful women in the cool outfits pulling the cable and plugging it in and saying, hello, this is the operator.
Mm-hmm.
You remember that?
Yeah.
Those are, okay, so I want you to keep that mental image, because those are the old style switches, right? Physical connection between two things.
Mm-hmm.
I'm the operator, and I'm gonna say, connect me to this location, and she's gonna grab the wire and plug it in. Well, at one point in time, that was a system, and then they advanced it. Now it's kind of an automatic switching based on like a code system. But the same principle exists, right? You connect one wire to one location.
Mm-hmm.
So that meant that with centralized switching, that if again, at the time, the Ruskies, and I use that term simply because it's hilarious, or whoever were to attack the United States, they could simply shut down a huge portion of communication by getting a few centralized switching offices. So the military said, look, we're paying for this. We want it to be more robust than that. We want it so that way if Atlanta were to get taken out or DC were to get taken out, it will be able to withstand that. It will be robust.
Mm-hmm.
And so what they did was they basically said, we need to abstract physical connection from what's actually going to happen. So what they did is they took these, again, the signals that are going on networks. They decided that they're going to create something that defines where a thing is without demanding that you go through the same wire to get there. So they created this web of wires. So a connection, in theory, can go from any position in the web to any node or location on the web, and then to back into its target destination. So think about it like an airport. So let's say we're in Orlando and we wanted to fly to San Francisco. So some carriers will get us from Orlando to Atlanta to San Francisco. Some carriers will get us from Orlando to DC to San Francisco. Some of us will go through Chicago. Some of us could go through Detroit. And all of these connections will still end up with us in San Francisco. So imagine that this class were to take a field trip to San Francisco. Would it matter what planes we got on, assuming that we all got there at the appropriate time?
No.
Not really.
No, not at all. In fact, it would be fundamentally irrelevant.
Mm-hmm.
And that's exactly how the internet is designed. It's designed so that when a message is sent, it's broken into little parts. And each of those parts is assigned basically a container to tell it where to go, and then it's shipped out. And it will bounce around to whatever locations it needs to go to, and then eventually reach its destination. But again, it can go through Chicago, it can go through Detroit, Minneapolis. It doesn't matter what connections and what points it passes through, because at the end of the day, it's going to reach its unique destination. And the definition of uniqueness is defined by what we call an IP address. Mm. Are you guys familiar with this term?
Yes.
Yes.
So, real quick. So this is, again, let me just go through the slides just so we cover it all. So again, we're abstracting the idea of the physical and logical, right? So the logical being this idea of an IP address, a logical identifier, physical being the wires. So we look here, these are IP addresses here. We see in the middle of the screen, we have IPv4, which is version 4 IP addressing and IP version 6. Again, so imagine this. When we say IP addresses, they're unique, right? How many 1234 Main Street, Orlando, Florida 32817s can there be?
One.
One, right? Again, we'll forget like east and west and north and south or any of that other weird stuff that they do to the street names. But again, assuming that a unique street, a unique address, a unique zip code, a unique city, all of those have to occur in order for mail to be delivered. Same exact thing happens with IP addresses. They need to be unique. Now, there's basically they ran out of IP addresses because IP version 4, it wasn't designed to deal with the number of devices we have. So IP version 6 was created to kind of help with that. But they have like a bunch of hacks to kind of handle IP version 4 addresses with public and private, what's called public and private address spacing, but we don't need to worry about that yet. The principle here is simply that unique IPs are assigned to each device. And those unique IPs are what define it in the World Wide Web. Make sense to everybody?
Yes.
Okay. So there's one other thing you got to know about, and that's physical addressing. So in addition to this logical addressing, there is still a physical address assigned to the device. Those are called MAC addresses, and you'll see it at the bottom. You see it like at the bottom of the screen. MAC address is the name. Okay, that is the actual address of the hardware. So when we talk about let's say the cell phones we're talking on, or the computers we're using, or and specifically the wireless card and the wired card, each have unique MAC addresses. Okay? So that basically is just a physical identifier of that thing.
So your IP address is really like your cell phone number, and your MAC address is really where you reside.
I think you're pretty close, yeah, because you can switch your phone and your number, right?
Yeah.
Well, it'd be like your cell phone number and then the serial number on your mobile device, right?
That is exactly what we're talking about. And again, my point was simply that because you could sell your phone on eBay and someone else could get a new phone number assigned to it. So again, it's dynamic. It's logical. It's not physical. But the serial number is not going to change.
Correct.
Right.
Okay. Again, when we talk about packet switching, we got to keep in mind the way it works is just like we're talking about separating a class into pieces. You know, the whole class room full of people. You're not going to like consider a class one clump of humanity. What you're going to do is you're going to break it up into pieces and then ship it as you need to ship it to get to where you want it to be. Again, and think about it again. Let's talk about this plane analogy. Imagine that we had a class of 50 students. How likely is it that we are going to be able to get all 50 students to the location that we want them on the same flight?
Not likely.
Probably not likely, right? And then, so what happens if and imagine that if any one of the students didn't get there, we had to start over. That would be really inefficient, right? Yes. So what they did is they decided that the best way to approach this is to break everything into small, manageable chunks, then assign addressing, number those chunks, put some stuff in there to validate that they're good, and then ship them off. So that way, when each piece gets to the other end, it gets checked, unpacked, assembled, ordered, and then put together as a single thing, and then that thing is pushed to whatever application it needs to go to. You following that?
Yes.
Okay. So think about it in terms of email. What happens when we talk about it from your machine to my machine? So you're going to send me an email. You basically do the following. You use an application. That application creates the email. So you interact with the application. Then, when you hit send, all the processes that need to happen to get it to become a data stream have to occur. They have to shoot across the internet. It has to get to my server, my mail server. and then I have to reach out and grab it from my mail server and pull it down, right?
Mm-hmm.
Okay, so that process, that occurs in email. It also occurs with websites. So if you get that that's what's going on, it helps you to understand if there's a browser-related problem or if it's a network-related problem, right? So if for some reason you can't load your website with Firefox, but you can load it with Internet Explorer, we'll pretend like that could actually happen, you could probably determine that that's not going to be a networking issue, but that may be a code-related issue, or it may be a problem with the individual's copy of Firefox, right? That makes perfect sense.
Right. Mm-hmm.
Okay, so there we go. So when we talk about email, remember I said there's got to be this big process that happens in order to get email from you into a format that can then be transferred. Well, the way that happens is there's a set of rules that govern how email is converted, transferred, and interpreted on the other end. And those rules are called protocols. Protocols are just rules for how things get dealt with, okay?
Mm-hmm.
So, common protocols. SMTP, or Simple Mail Transfer Protocol, is one I would know. I'd know FTP, SFTP. FTP is File Transfer Protocol. SFTP is Secure File Transfer Protocol. And there's also FTPS, which is another version of secure. It's a little better, but that's neither here nor there. You just know that each one of those is just a secured version. And then you can guess HTTP, which is the common web traffic, is the Hypertext Transfer Protocol, which is, again, if you look at the URL for any website, you usually see right at the beginning what?
HTTP.
HTTP:// And what that section of the URL is telling you is the protocols that are going to be used to govern this interaction. Okay, it's just defining the rule set. So if HTTP is the Hypertext Transfer Protocol, what do you think HTTPS is?
Secure.
That's it. Fairly simple. So, so there's also TCP, and it is basically what handles kind of the establishment of connections between devices. It's what kind of helps you to make those connections viable between your IP address, and it keeps those connections alive. And we'll talk about that in the networking section. Again, just think of protocols as the language. So again, same way you might speak Spanish or French. One application doesn't necessarily speak the other application's language, right?
Mm-hmm.
So you can use things like Microsoft Excel. You might be able to open certain types of documents that you might not, like a CSV, because it speaks that language, or an XLS or an XLSX. And there's some other formats that it will open. But each one of those protocols is usually tied to an application or a service or a process. So just keep all of that in mind. Does that make sense to everybody?
Yeah.
Okay. Hold on one moment. I have a student who's begging for the link. Let me send them a text. In the class. Okay. All right. Okay, so here's the first question I have for you guys, or the next question I have. When we talk about domain names, like Google.com, you guys know that's called the domain name, right?
Yes.
Okay, so how does that get converted into an IP address? Because remember, we talked a minute ago about what's the unique identifier logically throughout the internet? IP addresses, right?
Mm-hmm.
Well, IP address is the unique identifier. That means that every URL, every domain name needs to be tied to an IP address. So the process for doing that is what's called domain name servers or domain name services, and they basically translate what's going on the internet and what we type in human language into something that the computer can actually translate and find. So again, it translates that resource to and fro. So it basically, it takes that, what's called the URL, Uniform Resource Locator, and it turns that into an IP address. All right, there are 13 major groups of these things, and what you need to know is that these guys are really the backbone. So if anybody here's registered a website, what you do is you just jump on the website, or you jump on one of like GoDaddy or one of these other website domain registry systems, and you just type in your information, type in where your IP address is, and then it propagates across the world. So you'll see, when you do this, it usually takes up to 72 hours to take this information and make it universally available. And the reason is because it has to send it to each one of these locations. And you see the little dots there. It puts it all over the world. And so over the course of that 72-hour period, it will propagate its way around the world. Make sense to everybody?
Sure.
Yeah.
Okay. All right. So real quick, DNS breakdown. Most of them are in Europe. Just behind that is North America, and then Asia, and then the rest of the world. So again, we in Europe have a majority of the DNS servers. So we do most of our work, or most of the work in the internet is done in those locations.
I've always wondered why it takes so long for it to change over when you make changes to your name servers, why it takes so long. But I mean, I know that's a lot of different places, but it just seems like these days computers can do things so fast that it just seems like a really long time, 72 hours to do that.
Oh, it is incredibly
wiring.
Well, remember though that it has a huge number of those things to do, and it takes you have to basically put it in the queue. So it's going to add to the queue, and then whatever their cycle time is for doing updates is when it's going to get loaded in.
Okay, so you kind of go on a waiting list with everybody else who's making changes to their name servers.
Yes.
Okay.
And the reason, I mean, in reality, if you were the only person there, it would take like a hot second, but there's a huge number of people. So,
I see.
And remember, the volume of traffic is fairly substantial at those locations.
Right.
So, so the scheme, let's talk about this. So the URL in pieces and parts. So we have the scheme, which is the thing we talked about at the beginning, right? You know, HTTP, HTTPS, the protocol that we're using. Following that, we have the domain, and then after that, we're going to have ports. So ports, and we'll talk about this again in a second, or at least brief over if you get it. The port is basically a numerical address that is kind of a sub-level address on the local computer only to define what applications certain traffic goes to. Okay, does that make sense to everybody?
Yeah.
In other words, this server is a FTP server. It's going to have an open listener on port 20 and 21. Those are the FTP ports. When the FTP port is listening, when you put in a request, you're going to put that request at a specific port. You can use non-standard ports if you want, but typically people just use the standard ones. And so you're going to point your request at that port. When the request comes into the computer, the request will go in to the networking card, and then it will kind of go into the operating system and say, hey, I'm port 21. Send me to wherever you're supposed to send stuff that goes to port 21. And it sends it to the waiting listener that's sitting around going, hey, you got anything for me? And then it makes the connection. Does that make sense to everybody?
Mm-hmm.
Okay, same thing happens with every other port, right? So 80 and 443 are internet traffic. So internet traffic, when you set up your LAMP stacks, they're going to be listening on 443 and 80 for HTTP and HTTPS requests. That's what they do. All right. So when we talk about them, then from there, that's that first three pieces. The path. So this is, you have a website sitting on your computer, and the path to each part of the site is actually just a series of documents that are within folders on the server. So the path is the same thing as a local file path, right? So if I told you to go to, again, I don't know, Windows users, if I told you to go to C:\\/ desktop, that would put you on the desktop of the computer, right?
Yes.
So that is a path to that. Or if you go to, you know, /user/your username /desktop for a Mac user, that would be where their desktops were.
Mm-hmm.
So that is the path. And the same thing happens when you talk about websites. Websites have a path that direct you to a specific location. And again, it's just files within folders. So then once you get past that path portion, you'll see that there's something called a query string, and that's just basically either URL variables or data you're pushing to and from. And then after that, you have what are considered fragments, which is again a more specific piece of information. Now, this slide down, or the actual slide that you're seeing, the link to that slide is down below. So if we were to look at the actual presentation, this is the definition for this slide in edit mode. So when I went to edit this slide, I simply copied in the URL, and you can see each of the pieces, right? So you can see that we have something, it's in HTTPS, it's in //docs.google.com, so that's the domain. And then inside of that, what's the path? Presentation /d/ that big long string right there, all the way up to /edit. And then what do you get? You just have a fragment after that, which is the #slide equals the specific slide ID.
Mm-hmm.
Does that make sense to everybody?
Yeah.
Mm-hmm.
Perfect. All right. So again, at a very high level, a server is what? I have a question. How do you know a device is a server? How big does a server have to be?
At least 2 computers, maybe? I don't know.
Not a clue.
Well, there is no rule for how big it needs to be. Because again, when I started doing this, I always thought that a server had to be something huge. And nowadays, you can pretty much serve from your phone. Because if you think about it, if you have, like I have an iPhone, and so we have, what's it called? Not AirPlay. Basically where you can AirDrop. So I have AirDrop. So I can serve up to people content from my phone. I can AirDrop them files, right? So that means I'm serving content from my phone to people in the area. I'm using a different protocol to do it. There's a different set of rules, Bluetooth versus, you know, your normal HTTPS traffic, but it's still the same thing, right? We're still just serving up information.
Right.
So a server is simply a device that serves. A client is a device that connects to that server. That is the only set of defined rules that you really need to concern yourself with. So if you understand that, type of relationship, it'll make a lot, and the fact that there are no constraints for size or number of processors or any of that, and it is simply the fact that it can serve, that will actually, and I'm going to hate to say this, but that will serve you well in the future. Oh, funny. I felt so bad about that one, but it was just there. All right, so operating systems. So there's a lot of them out there. The primary ones that you're going to see are Windows, OS X, and Linux, and that is in not the right order. It should be Linux, Windows, Mac-based operating systems, and then everything else. We'll talk about mobile. We can talk about iOS, which is the Mac operating system for iPhone, Android, which is the Google app, Google operating system, and then the Windows has their own version, and there's now becoming more and more of them out in the market. And that's a whole different animal. But again, as long as you understand what these are, you know, kind of know what they are, you're primarily going to work, statistically speaking, you're going to work in a Linux environment. Linux is quote unquote free. It is incredibly useful operating system. It's something you can play with starting today if you wanted. It doesn't cost you anything to download, and it is tied to the most common web server, Apache. And so with that, and again, in this class, you're going to set yourself up a LAMP stack, which is Linux, Apache, MySQL, and PHP. And that whole process is the most common version of web development environments. So again, we mentioned the hosts. Hosts, basically, it allows for full two-way communication between different devices. Again, web servers simply serve up HTTP and HTTPS traffic. So FTP servers, guess what they do? HTTP traffic.
Yeah,
That's
transfer files.
Yep, file transfer traffic with a specific protocol. And then there's Tor servers. Who here's heard of Tor?
Not in a long time. I don't remember what it was, though.
Well, if you, I bring this up because it's important for you guys to kind of understand what it is. It is a protocol that the darknet runs on. It is kind of that underbelly of the network, of the World Wide Web. So they say that about 80% of the network of the World Wide Web is actually invisible. So 70 to 80%. But anyway, the take home is it is a very interesting place, but a very dangerous place. But it's just kind of, I thought it was important to mention it because again, it has a lot of potential security implications. Again, we mentioned what a client is. A client is what's a client? Anyone? There's a server and a client. What is a client?
The receiver.
The receiver, that's it. They're the ones that attach to the remote resource. All right, browsers. Browsers are simply applications that allow you to view remote web. Not even remote, it's just web content. So they're the interpreter for HTML, JavaScript, and then that's it. And so they allow people to kind of reach out and get into the actual content you guys are going to learn to develop or are in the process of learning to develop. FTP clients do the same thing. It is the application that you're going to use to interact with the remote device. So here's a question for you. Can your server be an FTP server and a web server at the same time?
I would think so. I transfer files every day, and I'm on the web too.
Then you got it. Yes, you can. You can make your server as many things as you want it to be, as long as you have ports available and the processing power and RAM required to run them. So simply keep in mind that when you design and you architect your kind of environments, that you know exactly what it is your intent is, and then structure your plan accordingly. So again, there's some advantages to having a bunch of separate devices, and there's some disadvantages. And again, you just simply have to kind of look through that and weigh it based on the individual rules and your individual constraints. Everyone follow that notion?
Yes.
Yeah.
Okay. Common ports, the ones I would memorize if I were you, 8443, 2021, and that's the ones I would memorize. If you know those, the rest of them you can look up and Google it in 5 seconds, and 5 seconds of web research, and you'll have it. So when we talk about web servers, let me switch topics again. When we talk about web servers, most common, Apache is absolutely the most common. I think it's like 60 or 70% of the market is using Apache. IIS is the Windows version of the same thing. It's just a Windows-based web server. There's also other like smaller niche market web servers out there. JRun is one of them, and that is, again, it's just another example of a web server. So what do web servers do? Serve
up the web.
I know that is exactly the answer I wanted to hear. They serve up the web content.
Yeah.
Right. So these are not servers. These are not web servers. PHP, Cold Fusion, Python, Ruby, ASP, HTML, these are not servers. You don't have an HTML server. Your web server may deliver HTML content. It may deliver Python content. It may help you to deliver or use PHP content or Cold Fusion content to develop sites, but it is not itself a server. So you got that notion. So those are web servers. So then let's talk for a second about database servers. The database is a targeted application for housing, collecting, and organizing data. You're going to deal with that next in DBS, which is like either your next class or the class after that. I don't know where you guys fit that fits in your plan. But you're going to start to get introduced to these concepts there. And basically, a database does nothing. It is designed to do nothing but store and read data. That's it. So it's reading and writing. That's all it does. Everything else is just additional overhead to kind of keep that secure, or to deal with what's going on the back end, or to make it so you can connect to it. But the fundamental principle of why you have databases at all is to organize and to store data. Okay, when you talk about databases, you got to talk about the language. So primarily the languages that are used are SQL. Most of the time you're ever going to do any database querying, which is what it's called, you're going to be using called the structured query language, or SQL. That is absolutely 90% of the time anybody does any database related work. That's how they do it. There's also other query languages like LDAP directories, which is basically an authentication authorization system. Again, it's simply a secondary database related language that I thought I would include to kind of give you a specific example of other languages that are out there. So when we talk about the databases, MySQL, absolutely the most common, unquestioningly. Following that, MS SQL is Microsoft SQL Server, another very good product, but it is very expensive by comparison. And then Postgres. Postgres is another free open source, and it's pretty robust. It's probably my personal favorite database server, but it is not the most common, so we don't teach it. But again, if anybody here latches on to things that they love, decide they love databases, Postgres has a great deal of power. It's a very good database language, and another corollary to MySQL. All right, so we talked about a little bit about what operating systems are out in the world. We talked a little bit about like some applications, so web servers, database servers, and so forth. That leads us to the next kind of slice of this pie. Let's talk about what users are, because inevitably in this course we're going to have to touch on this notion of security and how security applies to the world of the web. In specific, let's talk about what it is that you would want to have happen in your site. Imagine you have built a shopping cart, or you're using a shopping cart that someone else has built. Do you want to have a report of data leakage? In other words, data spillage, or somebody hacking your site?
No.
No. That's the kind of thing that gives you the cold sweats in the middle of the night. You wake up to that phone call, I promise you, you will not go back to sleep immediately. So, in order to address that, you have to give permissions. In order to give permissions, you have to have targets to give those permissions to, kind of definitionally, right? Because you have to be able to define what someone can do. In order to define what they can do, you need to define first who they are. So, when we talk about that, we talk about users. We talk about user accounts. We talk about the idea of what are called service accounts. But now, initially, you're not probably going to get too deep into this through the program, but I wanted to include it because I want you guys to have it kind of sitting in the back of your head. So when you design an application, you have to take into consideration what accounts that application needs to use, and then what requirements that those accounts that you decide to create are going to have. In other words, let's say you have two kinds of users. You have people who buy stuff from your website and people who audit the things that are bought, okay? So, should someone who buys stuff from your site be able to see the administrative audit screen?
No.
No. So, should the auditors be able to see the portion of the website that lets them buy things for people?
Yes.
So they should be able to go in and buy stuff on your account
Oh, no, no.
Right. So you would want to delineate what permissions each group has, right?
Mm-hmm.
And if you think your way through it, you should be able to say, well, I know these are the things that my site's got to have to do. And this portion is administrative, and this portion is applied and practical to the purpose of the site. So I'm going to make some stuff for the administrative people, and I'm going to make some stuff for the actual users, and I'm going to split that world down the middle. Okay?
Uh-oh.
And that's what user accounts do. Now, at the same time, we can talk about the idea of what's called a service account. So a service account is an account that is designed to allow connection not between people, but between the stuff that sits in on the back end. So again, if your database needs to talk to, let's say, your web server, and those two need to communicate back and forth, your web server needs to connect to your database, right?
Mm-hmm.
Method you might use to approach that is to create a service account on your web server and define very clearly the stuff that account is allowed to do. So for example, should the web server be allowed to go in and delete the entire database from the ground and burn the whole thing down?
No, that doesn't sound good.
Yeah, that's right. And I'm using this incredibly ridiculous example because I want to make sure you get this. You definitely don't want anybody, no matter how much permission they have, to be able to go into the database and just start deleting things at random. Right?
Right.
So you would probably want to create a service level account that would be able to tell people, hey, the web server only can do these specific things. It can write data to this section. It can delete data from this section. It can change data in that section. These people can do this stuff. These people can do this stuff. And I can control how all of that happens. And you kind of, all of that process, all of that kind of access control is what the technical term is for it. All of that has to happen through user accounts. All right. So if we understand basically what user accounts are, let's talk for a moment about the idea of trust. So trust is a way to define if someone is allowed to do something. So let me think of a great example of this. Imagine that you have a teenage child, and another teenage child wants to date said child, and you have never met this person before. Okay?
Mm-hmm.
So you have your child and you have this mystery child. What is the first thing you're going to do? You're going to probably assume that you know nothing about them, and you're going to either say, no, I don't like them, or you're going to say whatever and let the kid do whatever they want, right?
Yeah.
Those are basically your options. So which one do you think is more secure?
No.
Yeah, you're going to start with no.
Yeah.
But let's say that your best friend, who you totally trust, like is super, super best friend forever, and they're the most trustworthy person on the planet as far as you're concerned. They say, I know this kid's mom. She and I are friends. I've been hanging out with this kid's family for years. He's a good kid. She's a good kid. Whatever. It's a good kid. Okay? What are you going to do then?
Then you would probably trust them.
Right. Okay. So this analogy I want you to take into the world of computers. We do the exact same thing with computers. If my machine is allowed to connect to your machine, and my machine can vouch for another person, you should be able to trust that person effectively, right?
Mm-hmm.
Yes.
Computers, that is exactly how it works. So there are actually things called certificate authorities that are out in the world, and they're fairly expensive. And all they do is validate that you are who you say you are.
Mm-hmm.
And so this principle of trust is what's called transitive. And there's a problem. So imagine this. Imagine that we have, how many are of us in the room? There are 4 of us in the room. So imagine that I'm trying to communicate with the furthest person away, and I have 2 people between me and them. Okay, so imagine yourself in any of those positions, whatever. So, and person A trusts person B, person B trusts person C, and person C trusts me. If I'm going to pass instructions to A, will A listen to them?
No. Has to go down through the chain, probably.
Well, if I went right, okay. If I ask directly, they're going to say no, right?
Yeah.
But what happens if, however, I go, hey, person C, tell person B to tell person A this?
Then it's going to go through.
It'll happen, right?
Yeah.
Same thing happens with permissions. Same thing happens with user accounts. Same thing happens with systems. This is how hacking occurs. Transitive trust exists. That's the point. All right, we got that notion of trust under our belt? We feel comfortable with this idea?
Yeah.
Okay. Now we're going to get a little deeper into that idea when we get into kind of the operating system, kind of have an operating system level discussion, I think week 3. But for right now, we'll just have that kind of high level version. Architecture. So there's basically 2 kinds of architectures. And these go back to exactly the same thing we talked about at the very beginning of the discussion, in which we said, what are the different kinds of connections? We have physical and logical, right? So that same notion applies here. In a client-server relationship, if the server disappears, is there a connection?
No.
No, there can't be, right? Because the server is one device which serves. Okay? In a peer-to-peer relationship, this is what file like the pirating software does, like a lot of common pirating software. What this is it works the same way as a packet-based networking system. Okay, remember how we talked about that? We break things into pieces and we spread it all over the place. And if one piece goes down, every other piece picks up the slack. Okay?
Yeah.
All right, so these are the 2 different kinds. Peer-to-peer basically means there's no central location and that each device has some way to reach out and find out where other devices are, and then to act as what's called a seed for specific content transfer. Client server is I have a central repository. It is at a specific location, and like a castle on a hill, if it goes down, the whole thing goes down.
Okay.
All right, and these are the 2 types of architectures that are out there. All right, I got one more thing to talk about. So this is the OSI model. So the OSI model is a way to discuss with people and troubleshoot your way out of a problem with something that's going on the networking side of the house. Now this applies to internet traffic as well. And why is that? Because if we think about how the browser works, what's happening is that the browser from the user is converting traffic that is potentially encrypted, again, HTTPS. It is on a signal, or it's on a session, so there's specific variables tied to that. Anybody here heard of session variables?
No.
Okay, have you ever gone to a website and then shut it down and then popped it back open real fast, and had your whole you don't have to log back in or anything? You've had that happen. Okay, that establishment, that thing that's allowing that to happen is called a session. And what that is it's just a temporary set of files that are sitting around and saying, hey, I'm going to keep this connection available just in case they decide to pop back in. Okay, and so that's what that does. So when we talk about, again, these first 3 layers, the application, presentation, and session layers, those 3 pieces are really about presenting to the user, dealing with things like presenting that information, like encryption and decryption, and then finally establishment of processes running between different locations. So it's making the connections and establishing the connections at an application level. Okay? Below that is really where we start talking about things in the purely networking component. So when we talk about, specifically, let's talk about transport. So this is TCP. So what this does is this layer of the OSI model allows for ensuring that the the connections between where you're at and the remote location, the transfer of traffic doesn't have any issues in it. It basically orders. Remember we talked about the idea of taking packets and putting an order to them?
Yeah.
Okay, that's what this layer does. This basically says, hey, you have there's called a three-way handshake. So your device is going to call my server. Okay, so your device calls my server and it goes, hey, I want a request. My server is going to go, oh, you want a request? I'm ready to start that request. Your device will then look back at me and go, okay, I'm also ready to start the request. Let's go. You see, that's three ways. And at the end, the same thing unhappens. I'm done sending stuff. You're done sending stuff. I'm done receiving stuff. Okay, see you later. Disconnect. Okay, and so that's what this layer does. It ensures that stuff happens. Okay, so the next layer and the next three layers are about networking devices and logical physical connections. Okay, remember we talked about the idea of an IP address.
Yeah.
Right? IP addresses are all about layer 3. Okay? They are about what happens and what path things need to take to get from one location to another. If we remember back to my plane flight of classroom students to San Francisco, the networking layer decides which location we send each of the students through in order to get everybody there in a minimum amount of time. And it's all based off what's called shortest hop, but that doesn't matter. What matters here is that you get the notion that it is about the IP addresses, logical pathing, and ensuring that you have a clear path to where it is you're going, not based on physical location, but based on logical location. Data link, so this basically makes sure that you have physical addressing. So this is not quite as bright. This is this deals, remember we talked about MAC addresses? Okay, so this is what allows for another layer of allows you to ensure that things are going to get to where they're supposed to be. Now, there are 3 types of networking devices that are common. There are routers, switches, and hubs. I'm telling you this because if you remember these 3 things, they'll draw a parallel here in the future. So if I told you, do you guys remember when you used to be able to buy hubs as opposed to having a wireless router? You would just have a wireless access point, or you'd have a wired hub where everybody would come around and plug in.
Yeah, I used to have a Netgear hub.
Right, and you remember how the traffic would like flicker across the whole face of the thing?
Yeah.
Okay, and the reason that is because what a hub really is, it is a repeater that repeats every signal that hits it to every other line.
Right, so it's like a big mouth that just blurs everything all at one time.
It just sprays, it just like, imagine, it's like, it is the chattiest rumor monger in the world, because everything that comes, it gets sprayed everywhere.
Okay.
Okay, that is because it has no way to delineate what goes where. Now, back in the old days, they used to have switches everywhere, and that dealt with MAC addresses, because routers were really, really, really expensive. Like a 4-port router would be $350,000 in the 90s.
Holy crap! I thought mine was expensive. Goodness.
$400,000 for a single 4-port router. Okay,
Wow.
these are industrial size equipment, so this is not like your household, because they didn't have them. That's because then you would have basically, you would take your traffic would come into like a university or a large institution, and it would hit a router, and that router would then split the traffic into pieces based on IP addresses. Those would then be sent out into that layer 2, that data link layer, and at that layer, it would hit the MAC addresses and a device called a switch, and that switch would spray out, or delineate, not really spray out, but like shoot out to specific MAC addresses the types of traffic that it was requesting. Okay, and then So now if we talk about it, we talk about at that layer 3 IP addresses, routers. That's what we have in our homes now. Like I have a wireless router at my house. That is the commonplace. Again, everything is logical. Following that, we have the data link layer. That's the old switching style, and there's still in institutions that run off of these. In fact, larger businesses will still use them because they're really, really cheap for the number of connections you get. And then finally, you have physical connections, and those are the old hub style, and that is really the why. It's just a repeater, and these are the actual wires that kind of connect things in the 1s and 0 level communication. It is very, very, very low level. So when you learn this, I would especially look at that first column right there, and I will make these slides available to you guys. And there's
great! I definitely screenshotted that.
that is great too. I'm gonna put out a link here today or tomorrow in which I will send you guys out connect you guys all to my Google Drive so you guys can see all of these slides.
Yeah, because this slide right here has a lot more information than that one video we're watching. It doesn't really give a whole lot of detail.
Yeah, and I took the test too already, thinking that I don't know why I thought it was I had to do it by yesterday, and I took the test and completely failed it because this has way more information on it.
Oh, I'm sorry about that. I opened everything up at the beginning so everyone could have access to it so they could take it at their leisure. And so I wanted to make sure I included this. I don't know if there's any way I can reopen it. I don't think there is. So I really don't know. Again, this is FSO issue, and we'll take this offline if you want to discuss it further. But let me finish this discussion point. So I guess I'm done. So do you guys have any questions about this in specific? Does this make sense to everybody?
Yeah, the levels make a lot more sense now that you kind of broke it down some.
Yeah, and the extra text on it definitely helps.
Okay, and then the word game that I use is the all people seem to need data processing, or Domino's Pizza, or daily petting. I don't know if pick something that resonates with you, and then anyway, it'll help you to memorize it. And again, this is not a joke. This is not like lip service. I have been asked about this at 2 different job interviews.
Really?
I swear to you. I went in as a web developer for a company, and I went in as a security expert at a company, and both jobs asked me about this model. It may be an anomaly. It may be simply a happenstance event, but without a doubt, I've been asked on 2 occasions about this specific model. So again, and the reason it's useful again is nothing else, you can communicate with people, right? If you can say, I'm getting data, but it's still encrypted, where's that error going to occur?
The encryption is well, it's at the application level, right? You said that the browsers take the encryption of like the protocol language.
The presentation?
It's a presentation. Okay, so does that mean, so if we know that it's an encryption issue and we know that it's probably a presentation, that means that we can, 1, assume that the session probably is established because we've gone through and troubleshot that. So that means we don't need to think about anything from the networking end. Now we just need to figure out if it's a code-related error, like how we built the encryption. So again, as you troubleshoot, think about it this way from the server perspective. Let's talk our way through this. Some guy calls you and says, your server's down, okay, so what are you going to do? First thing you're going to do is make sure you're on your network, and then you're going to try to connect to it. Let's say that you can connect to it, but it's not serving the page. So what do you do then? Well,
we can connect to it.
So, okay, so you can ping it so it's up. So then what you might think then, what I would think then is, well, maybe the web server's got a problem. So let me validate that it's establishing transport. It's actually, like, I know that I can get to it. So I know that the TCP system's working, right? So I know I have an IP address. I know that it's up. I know that the flow control is working, but I don't necessarily know what, like if there's some problem beyond that. So what I might need to do then is say, okay, well, what other ways can I get in? And so, and in this class, you're going to learn how to do this. You'll SSH, which is secure shell your way in. And if that works, then you can go in and try to troubleshoot your way past that. So again, initially, you're going to just check the thing, make sure it's up. You're going to make sure that the IP address is visible. You're going to try to go in various ways. Then, if none of that works, try to go in through things like SSH or through your FTP client or what have you to try to see if there's other services that are up and running. And if those other services are up and running, then you can troubleshoot it down and say, well, then it's probably related to my web server. The web server's maybe having misconfiguration. Maybe someone hacked it. Maybe the page that you're loading has caused some problems on the front end, and you can actually get to the pages that are behind it, but you can't get to that main page, so it looks like it's down. Again, but you can go through this process in a very systematic way, and this kind of helps you to do that. Does that make sense to everyone?
Yes.
Excellent. All right, do you guys have any questions before I let you go? Because we hit an hour, and it's 7:02, so it's the end of the official class time.
I do. I don't know if Christina had do you have issues getting onto some of the links?
Yeah, there was one that was a dead link.
Yeah, I'm trying to pull it up now. And the Linda one, the actually install LAMP, that one I can't get onto Linda. I don't know if once I click on to sign in, it gives me some weird.
Okay, Linda's been giving us some issues lately, so if you'll send me the link, just send me a quick email with the link in it. I will try to get on top of that tomorrow and get that sorted, so that way you guys will have the appropriate links. And then again, we'll get that all fired off. So do we have any other questions about the content?
No.
Okay, I'm going to shut off the recording and then I'll answer